Hello guys and welcome back to my video. So in this video hello guys and welcome back to my video. So in this video we'll be talking about about callbacks. So guys, as you'll be training neural networks, there is a time and a point whereby your neural network will start learning, right? There will be no improvement to the loss function, right? So to prevent that, or for you not to waste your resources, because I know that some people will be training neural networks on you'll be renting computational power. So for you not to waste your money, to waste your money training on something that is no longer learning, that's where callbacks come into play, right? So today we are going to be taking a look at two callbacks. We'll be taking at the model checkpoint and the early stopping callback, right? So let's so let's so let's continue with our video. So let me just run a few things. So when using we use what we call the model checkpoint. So the model checkpoint, we use this callback when we want to save the weights for the neural network at a specific time, and point in our model training, right? Let's say you are training your neural network model, and then it reaches the maximum validation accuracy and no longer improving, right? So you want to save that maximum validation accuracy, so that the next time when you train a neural network, you are not starting from scratch, but you are starting from somewhere, right? You are starting from where you left. That's the reason for using the model checkpoint. So the first thing is we need to provide you the path. This is the path whereby I want to save my weights, right? And then we initialize the model checkpoint. Is called to tf.keras.callback, and then we then call the model checkpoint class. We provide it with the file path, which is the path that we created here. Save weights only. True, we want to save our weights only. Monitor, we want it to monitor the validation accuracy. And then we have the mod, which is the max. That means that we want only to capture the maximum validation accuracy, right? So if you don't understand what is the validation accuracy, I advise you to go and check out my video when I talked about training dataset and the validation dataset. Save best only. Yes, we want to save the best weights only, right, on our neural network. We want to save the best weights only on our neural network. And then the next callback will be the early stopping callback. So callbacks is called tf.keras.callbacks, early stopping. We want to monitor the validation loss, and then we provided another parameter, which is the patience. We want the patience to be 3. So this simply means that after 3 epochs, if our model is no longer improving after 3 epochs, then we need to stop our neural network. We need to stop training if it no longer improves after three epochs. That's what this patience value stands for. This patience parameter, that's what it was made for, right? So the next thing is we then compile our neural network. We provide the optimizer as Adam. We then provide our loss function metrics, and then we then fit we then fit we then fit we then fit our dataset into our neural network. We provide with the training images, training labels. We want you to train for an epochs of 25 epochs, right? The callbacks, we then provide our two callbacks. We have the model checkpoint callback and the early stopping callback, and then we feed it in a list, right? And then the validation data, we want it to be the test images and the test labels. So once you are done feeding the callbacks to the neural network, you then let your neural network train. So when our neural network will no longer improve, this callback, the model checkpoint will save our best validation accuracy and will save our best weights. And then the early stopping module will stop our neural network. For now, guys, let me leave the neural network to train, and then I'll be back when last time I said that we're monitoring the validation loss, right? So we're monitoring the validation loss. So as you can see here, the loss was changing, and the validation accuracy was increasing. But when we hit at this point, you can see that our module was no longer learning. that means it was no longer improving. As you can see, 1.0269, 1.0226, 1.0539. As you can see, even the validation accuracy is no longer increasing. As you can see that our neural network stopped training on the epoch 11th out of 25th epoch. That is because the early stopping callback simply stopped training when it saw that our validation loss was no longer increasing. And also, if we check into our files, right? If we check into our files, right? Let's go on to TMP. Let's go into TMP, and then let's go on to weights. As you can see, if you go on to TMP, you can see that we have our weights here. We have our weights that were saved. That is the best. That is the best weights for our model. That these are the weights, right? That means that our model has saved the best weights when we trained our neural network. As you can see, it was no longer improving. As you can see also from the training accuracy and the validation accuracy graph, you can see that from this point, this orange line is representing our validation accuracy. Our model was learning, it was learning, and then it reached at this point that our model was no longer learning. Thus, the early stopping callback then terminated the training process. That means that if you are running on paid GPU, that will also save your costs, and also it also saves your time, as you don't want to spend the whole day training a neural network that is no longer improving. So here, now that we have seen how to use callbacks, in the next video we are going to be looking at how we can fine-tune our neural network, how we can make our neural network learn properly. So thanks for watching, guys. Make sure that if you have not clicked on the subscribe button, make sure you click the subscribe button and click the like button. Thanks for watching this video. Cheers.